Hello class, so let's look at number 6 from year 2010 form B. Alright, so first I want you to look at the question a little bit and then see what happens here. We have two particles, one particle P, position was given in this way, and then particle R, its position was given in this way. Alright, so first A. Find all times T during the particle. The fact that particle R is moving to the right, this implies the velocity has to be positive. How do you find the velocity? Velocity will be the derivative of the function r. So here we have r prime. What is r prime? We have 3t squared minus 12t plus 9. If I set this one equal to 0, then I will be able to get some values here. So here we have, I can divide all by 3, and we have t squared minus 4t and plus 3 will be equal to 0. Then you will realize that t minus 1 and t minus 3 has to be equal to 0. That tells us that t can be equal to 1 or 3 to have the velocity to be equal to 0. Then if I were to just draw the number line here simply, this is 1, this is 3. Now given that this portion is 0 and then this portion is 6, which is given interval, I'm looking at the portions where velocity is positive. Since this is a parabola with the leading coefficient is positive, then if I were to sketch this one on the x-axis, then graph would look something like this. As you can see here, I have positive, and then the middle portion will be negative because below the x-axis, imaginary x-axis. So therefore, these will be the signs of the velocity. So when is it moving to the right? Okay. To answer that, that's when t is from 0 through 1 and 3 through 6. Oops. Alright, let's look at part B. Here we have find all times t during which two particles travel in opposite direction. Once again, direction is determined by the velocity. So here we have, I know the velocity of the particle r. So let's try to look at velocity for particle p. So I'm looking at p prime. What is p prime? Derivative of this. So we have negative 2, derivative of cosine becomes negative sine. So we have negative 2 sine of that expression, which is pi over 4 t. Now, but by the chain rule, I gotta multiply this one more time by the pi over 4, which ends up being negative pi over 2 sine of pi over 4 t. Now notice the frequency is pi over 4. What does that mean? By the period, since the period is equal to 2 pi over pi over 4, we realize that period is 8. That tells me, or that tells us, that starting from 0, we could have a sine curve going backwards because the leading coefficient is negative. So we would have had this way. Or you know what? Let me make it a bit bigger. Where it finishes, this must be 8, and this must be 4. But our domain is only up to 6 here, and then here becomes 2. Now, then you will realize that 4 to 6 is positive. The rest of them will be negative. Then, if I were to put these two things together, transpose one on top of the other, to see when they're traveling in opposite direction. So let's look at it. 0 through 1, while r is going positive, this one is going negative. So we are looking at 0 through 1 is a 1 interval. So we are looking at t such that 0 through 1 is 1, and then or how about 1 through 4 is the next 1 through 3 is negative, but here is also negative, so it doesn't really matter. Now, but 3 through 4, which is this next value, 3 through 4, while this one is positive, while this one is negative. So another condition is 3 comma 4. And then, so how about 4 to 6? 4 to 6 is positive, and 4 to 6 here would have been positive also. So that's about it, I guess. Those are two intervals where particles will be traveling in opposite direction. All right. Number C. Find the acceleration of the particle p, that means double derivative, at time t equals 3. And then is the particle p speeding up, slowing down, or doing neither at time t equals. So now let's try to look into this one. So here we have part C. We are looking at the acceleration of particle p. That means we need to take another derivative of that. So p double prime then is equal to, from p prime was here, then we'll end up getting negative pi over 2 times cosine of pi over 4 t. Derivative of sine becomes cosine, but we have to go for the chain rule here, which ends up being pi over 4 once again. So here we have negative pi over 8, pi squared over 8, which doesn't affect the sign, by the way, of cosine of pi over 4 t. Now, when t equals 3, that's our question. When t equals 3, we realize p prime, which is the velocity from the previous function, when t equals 3, then we end up getting negative pi over 2 sine of 3 pi over 4. Now, what is 3 pi over 4? That's right, that's the same thing as 135 degrees. Since sine will be on the second quadrant, this will be positive, but due to the leading coefficient, this will be negative. So we know that the velocity is negative. But how about acceleration? P double prime. Negative pi squared over 8 and cosine of 3 pi over 4. Double derivative would have been this way, and then while cosine is in the second quadrant, cosine will be negative, while we have another negative that makes acceleration to be positive. Since the velocity and acceleration have different directions, so we realize the particle will slow down. Since velocity and acceleration are opposite in directions. Alright, so that's basically what we can say. Let us look at part D. Write but do not evaluate the expression of the average distance. Now, average talks about the some sort of mean value theorem, but we're looking at the average of what? Average of distance between the two particles. Distance can be calculated by the difference between two positions, but distance, since it's a scalar quantity, we have to put the absolute value. So number D would have been this. We are getting the absolute value of r of t minus p of t. Now, average distance between two particles on the interval 1 through 3, so we have 1 to 3. Now, actually, this will be the position. So, in fact, I'm sorry about that. We don't need to use the, what do you call that? That's what we have to do. That's right, we gotta go for dt over 3 minus 1. That becomes the average distance between those two values. All right, that's it. Have a nice day. Bye-bye.